Hello guys, welcome back, and in today's video we're going to discuss about electrolysis of aqueous solutions. Now, let's take sodium chloride solution as an example. So the difference between the molten sodium chloride and sodium chloride aqueous is that when it was sodium chloride molten, the only ions that are included is Na plus and Cl minus. But if it is sodium chloride solution as it is now, because of the water solution, we are going to have water in sodium chloride. So all the ions involved should be Na plus and Cl minus from sodium chloride, and since this is a solution, it is going to involve H plus and OH minus as well. Now we've got to think about something. We have two positive ions and we have two negative ions. Which one will be discharged among the two positive ions and which one will be discharged among the two negative ions? So in order to answer this, we must use the reactivity series for positive ions, and we must use the information on the right side for negative ions. So positive ions, we are going to select H as our standard, and if our element is higher in the reactivity series, it is not going to be discharged. So Na is here and H is here. So hydrogen will be discharged because it is less reactive than sodium. So the equation should be H plus aqueous would give us hydrogen gas, and if we balance the equation, we should get this one. For the anode reaction, we are going to select Cl minus and OH minus. So you should know that the fluoride ions are the easiest to oxidize, which will be easier than OH minus, so Cl minus will be discharged at the anode. So the equation will look like this. And if we're going to balance the equation, it is going to look like this. Now, I'll teach you now how and why to use this reactivity series and the one on the right side. Now, if we're going to compare between potassium and hydrogen ion, why is H plus ion discharged compared to K plus ion? So, K plus ion is more reactive than hydrogen ion if we look at the reactivity series. Since it is more reactive, it would like to remain in the solution as an ion and not change back into an atom. And that is why H plus has to be discharged compared to K plus. But if it was between hydrogen and copper, copper would get discharged because this time hydrogen is more reactive than copper, and hence hydrogen would like to remain in solution as H plus ion while copper is discharged. Now let's take a look at the negative ions. So why are halide ions discharged compared to the hydroxide OH minus ions? It is because the halide ions are easier to oxidize than OH minus ions. Easier to oxidize means that, let's say, right, we have a halide, for example, chloride. It only needs to gain it only needed to lose one electron to become chlorine atom. So the chlorine atom here can simply combine with another chlorine atom to discharge as the chlorine gas. But if we compare OH minus to the polyatomic ions such as sulfate or nitrate, hydroxide ions are much easier than sulfate or nitrate to oxidize. So you should remember it this way. If it is between halides and OH minus, halides will get discharged. If it is between polyatomic ions and OH minus, polyatomic ions will get discharged. If you follow these two methods, it will become very easy for you to write down the equation. Now, let's take a look at this one. So we've already talked about this, okay? This is the same cathode and anode reaction for sodium chloride solution. Now let's take a look at this here. If we keep doing our electrolysis for a long amount of time, we will start to notice that the H plus ions will be used up and they will be gone. And similarly, at the anode, CO minus ions will be used up and they will be gone as CO2 gas. So what are we left with here? We are left with Na plus and OH minus in our solution, which will combine to form Na plus aqueous plus OH minus aqueous will combine to form sodium hydroxide aqueous solution, which is an alkaline solution. Remember this information because in exams, after the cathode and anode reactions, they might ask you to write down what is the remaining solution, or is the remaining solution an alkali or an acid. So as for the observation of electrolysis of sodium chloride, we can see that we are going to obtain less chlorine than hydrogen. But before we get to this, let's take a look at this. How can we tell what amount of gas are we going to obtain? Alright, so it's very simple. Now, 2 electrons. We would require 2 electrons to produce 1 mole of hydrogen gas. And we would also require 2 electrons to produce 1 mole of chlorine gas, as we can see. But when we do practical investigation, we observe that we obtain less chlorine than hydrogen. It is because chlorine is more soluble in water than hydrogen. And again, since we are producing gas, chlorine gas and hydrogen gas at the electrodes, because bubbles of gas are seen. Sorry for the typo here, this should be hydrogen gas. Now, since chlorine gas is very poisonous, as we learned in halogens, we need to use a fume board as we see on the right side, so that we are protecting ourselves from poisonous gas. Okay, so a fume cardboard is being used because the chlorine gas, which is going to produce from here, is very poisonous. For electrolysis of copper 2 sulfate solution, since it is copper 2 sulfate solution, we would have Cu2 plus and SO4 2 minus, and since it is a solution, we would have H plus and OH minus as well. So pause the video now to figure out which one is going to get deposited by yourself. Since copper is lower than hydrogen, since copper here is lower than hydrogen in the reactivity series, copper is going to get deposited at cathode, so it will be Cu2 plus aqueous plus 2 electrons would give us copper solid as our deposit. For the anode reaction, this is quite important. It is between OH minus and SO4 2 minus, and OH will be easier to oxidize than the polyatomic ions. So we're going to get this equation. OH minus aqueous will give us water, liquid, oxygen gas. Now, since this equation is quite complicated, I would suggest you to learn this equation by heart because it is always the same. 4OH minus 2H2O plus O2 gas, and to balance the equation, we're going to add 4 electron. Remember, learn this information by heart in order to write down the anode reaction. If your hydroxide ion is produced, it is always the same. And make sure that you are balancing the charges on both sides. Now let's talk about remaining solution. If we continue our electrolysis, all of the Cu2 plus will be gone and all of the OH minus will be gone. So we are going to be left with our H plus and SO4 2 minus. So we are going to have H plus aqueous plus SO4 2 minus sulfate ions, which will give us sulfuric acid H2SO4 aqueous, which is an acidic solution. If we test it with a litmus paper, we are going to get red. Now, what are some of the observations that we can see during the copper 2 sulfate electrolysis? So what we can see is that at first, the solution will be very blue. But after the electrolysis, the copper 2 sulfate will become paler because the reason why copper 2 sulfate is blue is because of Cu2 plus and SO4 2 minus. Among here, the blue color is because of the Cu2 plus ions. But if you can see here, Cu2 plus ions will be used up. So copper 2 ions will be used up, so the solution becomes paler. So instead, at the cathode, which is your negative electrode, Cu2 plus will be attracted towards the cathode, so it will form a pink brown solid, copper solid. Alright, and the bubbles of gas, okay, we are also going to see the bubbles of gas. Because why? Because oxygen gas is being released at the anode. So remember, at the cathode, you should have your metal deposit, and at anode, you should be observing bubbles of gas, because whenever some gas is being released, we are going to see bubbles. Alright, so let's do one for the dilute sulfuric acid. Since it is dilute sulfuric acid, we're going to have H plus and SO4 2 minus ions. Since it is dilute, we are also going to have water, which is H plus and OH minus. Since our H plus is the same already, we can remove one of them. So our cathode reaction would be only 2H plus aqueous plus 2 electrons would give us hydrogen gas. For our anode reaction, since it is between OH and SO4 2 minus, OH will be released. But the question here is, will we produce more hydrogen or oxygen? So how we can do this is by looking at our number of electrons to the mole ratio. So 2 electrons, when they flow, we are going to get 1 mole of H2 gas. But it will require us 4 electrons to get only 1 mole of oxygen. Meaning that if we actually use 4 electrons, we will get 2 moles of hydrogen. So we can say that twice the amount of hydrogen will be produced more than oxygen. Now, as for the observation, the amount of hydrogen will be twice than oxygen because of electron to mole ratio. I have already explained this a few seconds ago. But when you're doing practical examination, you will also see that the oxygen is more soluble in water. Let's say if you're producing oxygen here, it is soluble in the water, meaning that the hydrogen amount will be twice than oxygen because some of the oxygen will dissolve and be lost in the water, and that is the reason why. Now, pause this video now and take 5 minutes to learn this information by heart. Again, as I mentioned before in previous videos as well, you should definitely remember the reactivity series by heart, and the more reactive in the reactivity series, if we are comparing, let's say, hydrogen and aluminium, hydrogen will be discharged at cathode because it is less reactive. If it was between hydrogen and silver, silver will be deposited at the cathode because silver is less reactive than hydrogen. So again, the more reactive element would like to remain as an ion in solution. For the negative ions, the halides are the easiest to oxidize, so they will always be discharged compared to hydroxide ion or polyatomic ions. But if it was between hydroxide ions and sulfate ions or nitrate ions, OH minus is going to get discharged because it is easier to oxidize. So their discharge order would go this way. Alright. Now, try to fill up the following cathode reaction and anode reaction. Okay? And then pause the video to see if you actually got all your answers right. Alright, so I'll take you to one of them. So let's say we're doing potassium iodide solution, so we should know that we have K plus and I minus, and since it is a solution, we have H plus and OH minus. So between potassium and hydrogen, potassium is more reactive, so H plus will be produced at the cathode. So H plus aqueous plus electron minus will give us hydrogen gas. So to balance the equation, we're going to multiply with 2. At anode, between the halide and the hydroxide, halide is easier to oxidize, so we would get I minus reacts to give I2 gas plus 2 electron and balance the equation by multiplying with 2 on the left side. Now let's do a molten one. So if it was, let's see, dilute hydrochloric acid, we would have H plus and Cl minus. So since it is a solution, we will also have another H plus and OH minus. So H plus will still be the same as this one. And as for between halide and a hydroxide, we're going to have Cl minus reacts to give CO2 gas plus 2 electron and 2 Cl minus. Alright, so try to complete all of the table. I'll be sharing the answer now and cross-check if you actually got all of them right. Okay, so make sure that all of them are right, and if you get something wrong, try to go back to your solution and see what your negative ion is, what your positive ion is. Okay? Alright, so that is all for today's lesson, and then in the next video we will have some practice problem from past year papers. That will be all for today. Bye bye.